This video is going to be about multiplying and dividing rational expressions. We looked at rational expressions a little bit the other day on our Desmos activity that we were doing. We were looking at adding polynomials, subtracting polynomials, multiplying polynomials, and finally dividing polynomials. And that's what a rational expression is. A rational expression is a quotient of two polynomial expressions. So again, we're looking at dividing. Anytime we have some division of polynomials, that's a rational expression. And so again, another way to say that is kind of like fractions. Each of these is a fraction. Now, each of these is a rational expression. It has a polynomial in the numerator and a polynomial in the denominator. That's what a rational expression is. Let's take these three examples and just look at a little bit. This is looking ahead a little bit, but not too much ahead, on how we could reduce these fractions, cancel these fractions, simplify these fractions. And actually, to look at that, maybe as an example, let's start off with this last example just as an example. So my question to you is, could you cancel this x and this x, and that would be left with a 3 over -7? Is that how it works? Well, the answer is no. That is not how it works. You cannot just cross stuff out. You have to factor before you can cancel anything. So this does not simplify. This middle example, similar deal. Could we take the 10 and the 6 and we go, well, 2 goes into 10 5 times and 2 goes into 6 3 times, and so that would reduce down, and so our answer would be 5 over x squared minus 3. Is that how it works? No, that's not how it works. We cannot simplify those. And so if we look at our first example, though, this is going to be what I was talking about. I said a second ago, you can't just cross things out. You have to factor to see what factors go into each other. And this one, we know how to factor this. We know we've been doing this for a long time now, this is a difference of squares, and so we can factor it out. This is what we get when we factor it. Now, this factor of x plus 2 can cancel with this factor of x plus 2, and we're left with x minus 2 as our final answer. Now, these three questions that didn't ask us to simplify, but I wanted to use those as examples so that you can see what can and cannot simplify. And I'm going to go ahead and write here that these cannot be simplified. So please remember, you cannot do that. You cannot simplify those two. You can't just cross stuff out willy-nilly. Okay, but rational expressions can be simplified like fractions. And you do that by dividing out common factors from the numerator and denominator. So again, we have to factor. We can't do this without factoring. That is also to say, if you were not very strong in factoring, back when we did factoring with quadratics, and we did factor with polynomials, if you did not do very well with factoring, it is going to continue to haunt you. So please don't resist that and start to learn how to factor, and factor in the most efficient method. I personally like guess and check method. I think it's the fastest method out there. Some of you are still in the box method, or you're still using the AC method. That's fine as long as you can do it efficiently. In other words, it's not going to take you forever on a test. Okay, that being said, let's talk about how to simplify this. Well, we simplify it by looking at common factors. We know that 8 is a factor of 8 and 16. And 8 goes into 16 twice, and 8 goes into 8 one time. And then we just learned the other day about how to simplify how to simplify exponents like this. And so that is going to give us an answer of 2x to the 9th. Because I can simplify those because they are factors of each other, and I can simplify those because x squared is also a factor of that. We factor it out and we're left with x to the 9th. Letter B, we do need to factor it. I will give you a hint. Now this hint does not work every time, but my hint to you is often what I'm trying to ask you to do is cancel things. And so if there is a factor of 3x plus 4 on the top, there is probably going to be a factor of 3x plus 4 on the bottom. Not always, but I'm just saying that might be an easy way to start your guess and check and see if it works. So if I use that as my hint of my guess and check, then I can see by guessing and checking, I know I need to have a -1 here. That would be giving me -4 there. And if I check my middle terms, I have a -3x and a +4x. That adds up to a +x. So this is how this factors. I factor by guess and check. If you want to do it by AC, that's fine, but I do it this way, and I think this is faster. Now I have a factor in the numerator that can cancel out with the factor in the denominator, and I'm left with 1 over x minus 1. Okay, similar deal with example C. Again, we need to factor it. And whereas the first two examples were pretty easy as far as factoring goes, this next one is not quite as obvious. I personally prefer guess and check, but I know that a lot of you like the AC method, so let me quickly run down a review of the AC method. Let's say I'm going to take my denominator, and I'm going to factor my denominator by AC method. Well, in this denominator, the AC would equal -36. What I'm looking for is what multiplies to be -36, but adds up to be a -5. And so I can see now that's going to be a -9 and a +4. Now, for the AC method, what that means is I put those into my middle terms. That is, I make my 5x, instead of calling it a 5x, I'm going to call it a -9x plus 4x, because that does equal 5x. And now I'm going to factor by grouping, and I'm going to come up with my factors. So 3x goes in, or can come out, whichever way you want to say it, and 2 can come out of this one. And you have a 2x minus 3 and a 2x minus 3. So this denominator can factor down 3x plus 2, and then what's left over is this 2x minus 3, which is kind of like the GCF. That can be factored out. So that is my factorization of my denominator. Now, that to me takes a long time. I don't like it. If you want to do it, great, go for it. But now that I have done it, I can kind of use that as a hint of how to set up my numerator. Because again, probably, not always, but probably something is going to cancel. And so this time, since 6 is not prime, what I want to do is I want to take the one that is prime. So when I do guess and check, I want to take the one that's prime. That's the 2. And so I know this is a 2 and a 1. Now, back to my hint. If I go down here and look at these, ooh, there's a 3x plus 2. But there's nothing that has a plus 1. So I might put 3x plus 2. And then if that's a 3x and I have to have a 6x squared, that must be a 2x. And they're all pluses, so this must be a plus. That's just a guess. I still need to check it. So I'm going to check it, and my 6x squared plus 3x plus 2x, that's 7x, that's what it's supposed to be, plus 2. That works. I don't care whether you use AC method or guess and check or the boxes or whatever you want to use, but you do have to know how to factor. Now, I found a common factor. That common factor I can cross out of the numerator and the denominator, and I'm left with my answer of 2x plus 1 over 2x minus 3. Now, what about the 2x's? Can I just cross those out now? No, you cannot. You have to save those. Those cannot be, they're not factors. They're adding and subtracting. That's not factoring. You have to be able to factor it out, and this cannot be factored out, and since it cannot be factored out, we leave it like that. Okay, now let me back up because there's something in the instructions that we didn't really discuss, the domain. So we're going to talk about domain on each one of these. So over in the margin here, some things you need to write down. The domain is where the expression is defined or it does exist. So let's just briefly remember like a parabola. The domain of a parabola is from -infinity to +infinity because it exists everywhere. It does not have any breaks. But we saw some functions the other day when we were doing some of these with Desmos. We saw this one that kind of looked like this. Remember that? I think it's a little bit upside down, but it looks something like this. And there were these asymptotes, and those asymptotes were where it does not exist. And so those are not part of the domain. The domain is where it is, but then we have to talk about, okay, well, where isn't it? Okay, so remember that those asymptotes and a lot of what we're talking about here with domain deals with where is it undefined. And so if I look at my first example and I ask myself, where is it undefined? Well, the only variable I have here is x. And if this was 0, if x was 0, it would be undefined there. And so what I say is we use this, it's like a capital R, but it actually has 2 lines on it, kind of like the paragraph symbol that has 2 lines on it like that. So the capital R with 2 lines is all real numbers. So here, if I wanted to talk about domain, I'm going to say the domain is all real numbers except 0. Because I could put anything in there and it would be okay, except 0. If I put 0 in there, it would be undefined, and that's not part of the domain. So that's how we do domain. Let's look at it when we have something like example B. Now, even though we crossed it off, I am still going to include that as one of the exceptions in my domain. Let me start with one that's obviously here. So I'm going to write it out again. Domain is all real numbers except, well, if I look at my denominator, what couldn't I put in there? Well, I don't want the whole thing to be 0, and what would make the whole thing 0 in the denominator? A 1. So I'm going to say all real numbers except 1, because if I put a 1 in there, I'd have a 0 in my denominator. That would make it undefined. Now, I also want to go back. I know I crossed it off, but it still is kind of there. It's still going to bug us a little bit because really we need to go back to the original problem. And so think about it. If I set that equal to 0, and maybe I'll just come over here and make a little side note. 3x plus 4, if I set that equal to 0, what would x equal? Well, I would subtract my 4, and I would divide by 3. And so now my domain is all real numbers except 1 and negative 4/3. Because if I plugged in a negative 4/3, I would have 0 in the denominator. If I plugged in a 1, I would have 0 in the denominator. Take a second and look at example C and decide what you think the domain is going to be. It's going to be all real numbers except what? Okay, on letter C, the domain is going to be all real numbers except negative 2/3. I got that one from what I crossed out. And positive 3/2. I got that one from the one that's still left there. Because either one of those, if I plugged in either one into the original problem, I would have a 0 in the denominator. Of course, we know we can't have a 0 in the denominator, and so those are the exceptions. They are not included in part of the domain. So again, make sure you have this written down, that the domain is where the expression is defined or it does exist. That R, that's kind of an ugly thing there, that R is all real numbers. And then finally, do not cancel with adding or subtracting. You have to factor first. Okay, so that first set of examples were just kind of normal factoring, simplifying kind of problems. In this next section, I want to talk about factoring out a -1, specifically a -1. It says factoring out negatives, but specifically -1. If you look at example A, I think you can see a couple of things. You can see some similarities, first of all, and you can also see that the numerator is kind of out of order. It's not in standard form. So let's say I rewrote it into standard form. And if I rewrite it in standard form, I get -2x plus 10. Then I have a common factor, and that is 2. But actually, I can factor out the -2, because when I factor out the -2, that's going to give me x minus 5. So now I can cross out this version. I like to, as I go up, I like to cross them out so I don't kind of get confused with what's what. So I know that's gone because I already factored it. Okay, now this x minus 5 and this x minus 5 can be simplified. We don't need those anymore. So what we have is a negative 2 over 1, or just negative 2. That is what that simplifies down to. And then the domain would be all real numbers except 5. Example B. Once again, our numerator can be factored, and I'm going to factor out an x for sure, but I really probably want to factor out a negative x, because when you're in standard form, it's nice to not have a negative leading coefficient. So I get a negative x, and then x minus 3, because a negative times negative is positive, so that's going to give me the right thing. So I can cross that one out now. Now, using my hint from before, probably I need to simplify something, cancel something, so I probably am going to cancel out that x minus 3. And if that's one factor, then my other factor must be a 2, and then also a 1. I need to think about my signs. Well, a negative times a negative is a positive. So 2x squared minus 1x minus 6x, that is minus 7x plus 3. That's my factored version. I did it by guess and check. You can do it however you want. Now that I've factored it, I can see, oh, here's a common factor. I'm going to get rid of my common factor. And so now my simplified version of my answer. And then I also need to list my domain. My domain is all real numbers except, and there will be 2 because there were 2 factors. One of them is easy, it's 3. The other one, I just have to solve this, and I think a lot of us can just solve that in our head. We're going to add 1, divide by 2, so that is 1/2. So my domain is all real numbers except for 3 and 1/2. Okay, once again, pause the video here. Do letter C, factor it. You're going to have to rearrange it like we did on example A, rearrange it, factor out the GCF, factor out the negative, and then see what you get as your final answer. Okay, I'm going to rewrite my numerator into standard form. I'm going to factor out my negative x. So now that one's gone. When I factor out my negative x, I get negative x times x minus 4. In my denominator, x minus 4x plus 2. The x minus 4's cancel, and I get negative x over x plus 2. My domain, I have to go back even to the ones that were canceled out, and it is all real numbers except 4 and negative 2. Okay, let's turn the page. Okay, on the first page, we were just simplifying, just factoring and simplifying. In this section, we're going to be multiplying. And you have to remember your rules for multiplying. When you multiply fractions, you multiply straight across. So we're going to multiply straight across, and then after that, then we're going to factor and simplify. And so we go straight across, and in our numerator, we get 20x to the 8th, and in our denominator, we get 30x to the 5th. And we look to see what can we cancel. There's a common factor of 10, so I can definitely take out a 10. And these we need to subtract, and so we get x to the 3rd. 2x to the 3rd over 3. I need to think about my domain. My domain is going to be all real numbers except 0. We did an example like that, I believe, in yesterday's notes. So now we're getting into, okay, what if it's more complex like this? Well, factor. Factor first and then simplify. So let's take a second to factor all the different pieces here. Anything that can be factored, let's factor it. So I'm going to factor my first numerator, 10 times x minus 4, my first denominator, x minus 4, x minus 2. The numerator here, the second numerator, cannot be factored, so I'm just going to leave that like it is. But this bottom one can. It has a GCF of 5, so I'm going to factor out my GCF of 5. And so now, again, I'm going to cross out the ones I've already factored so they don't confuse me. I'm getting rid of those. This one has not been factored yet. Okay, now I can cancel the x plus 3's and the x minus 4's. And also, you can see this, 5 goes into 10 twice, so that can also be factored out. And so now what I have left is 2 over x minus 2. Now, can this 2 and this 2 be canceled? No, they cannot. Why not? They're not factors. You have to have a factor to cancel. Finally, I'm going to look at my domain. It is all real numbers except what? Well, I have to look at anything that I ever had in the denominator ever. And so I have a 4, I have a 2, and I have a -3. And I have to list all 3 of those because there were 3 different things in my denominator. So I have to list all of them. On example D, I need to factor my denominators. Both my numerators are okay as they were. So factor out that denominator with a GCF, factor out this denominator with difference of squares. Now the x minus 3's cancel, the x plus 5's cancel, and notice I have nothing on the top. And so over here in the margin, make sure that you write down something about if everything cancels, don't forget the 1. Sometimes people forget that. I'm talking about, look, everything's gone off the numerator. If everything's gone, make sure you put a 1 there. And then in my denominator, I still have 4 and x plus 3. I'm going to leave it in factored form. If you want to multiply that out, that is fine with me. You can do that. You just don't need to. Usually, if it's a test or quiz, I will say whether to factor it or not. If I don't say it, then just do either one. It doesn't matter. And then I can list the domain on this. So my domain is all real numbers except the 3 things that were in the denominator: a -5, a -3, and a +3. Do you remember how to divide fractions? Some teachers use this phrase, keep, change, flip. So maybe you've heard that phrase before, keep, change, flip. Some teachers use the phrase multiply by the reciprocal. So when we have a division with fractions, we multiply by the reciprocal. So I need to basically change this to a times sign and then flip this over. So I have this instead. And so again, my typical process is to multiply my numerator, multiply my denominator, and after I've done that, then look for my common factors and cancel things. So 4 goes into both of those, and I will subtract my exponents. And so my final answer is 3y over x squared. Once again, we are asking about domain, but I'm going to leave off the domain for this one again because there are 2 variables. This next problem, we have to factor it. There are 1, 2, 3, 4 different things that need to be factored. But before I even do that, I need to remember that I need to change this to a times, and I need to flip it upside down. So I'm going to go ahead and factor it, and then I'll flip it as I factor. So take a minute, pause here, factor out what you're able to factor. Okay, let me show you what I've done with my factoring here. My first fraction, I left it in the same place. That is, I factor my numerator, put it on the top, factor my denominator, put it on the bottom. For the second fraction, I factored the numerator, but then I put it down in the denominator. And now, this 8x squared minus 28x plus 12, you might not have seen it, but you can factor out a GCF of 4. And when you factor out that GCF of 4, then you're left over with this trinomial, and this trinomial factors down to 2x minus 1 and x minus 3. And now, since I've already factored this one down, I'm going to cross that out so I don't lose track of it. Now I'm ready to start crossing out factors. So I'm looking for common factors here. I have an x minus 3 and an x minus 3. I have a 2x plus 1 and a 2x plus 1. I have a 2x minus 1 and a 2x minus 1. And it looks like that's all I have. And so now I'm left in my answer with 4 times x minus 4 over x plus 3. And once again, I would just leave it factored. If you want to distribute it, fine, go ahead, distribute it, but I'm going to leave it factored. Now, I do want to talk about the domain here because the domain is a little bit different. For the domain, you might write this down over in the margin. For the domain, when you are doing division, for the domain, you have to list anything that was ever in the denominator. In other words, it could have been in the denominator before the flip, or it could have been in the denominator after the flip. Everything has to go into that list on your exceptions on your domain. So as I look at my problem, things that I ended up with in the domain were 3 and -3, 1/2 and -1/2. And then I have to go up and look about, well, what about in the earlier stages? Because in the earlier stages, they're crossed out here. They're kind of hard to read. We have a positive 1/2. Well, that's already on my list. And a positive 3. That's also already on my list. And so that does cover everything. But just make sure you understand that you have to list out everything that's there when you do this.